So in this video, we will discuss about introduction to the operational amplifiers. So this introduction, this operational amplifiers which is having two high impedance input terminal and one low impedance output. Okay, so opamp means operational amplifier, and there is nothing but a very high gain amplifier circuit. Okay, which has two high impedance input terminal and one low impedance output terminal. Okay, so this input terminal I can classify it as inverting and non-inverting. Okay, that is if I give the input positive input to the non-inverting terminal, means I will get positive at the output. If I give a positive signal to the inverting terminal, means I will get negative output at the negative signal at the output. Okay, so so this basic op-amp circuit, it consists of first one is a differential amplifiers. Okay, differential amplifier at the input stage. Okay, then it has a level shift. It is nothing but at the intermediate stage. Okay, and at the output stage you have a emitter follower. Okay, so what is emitter follower? It is nothing but a common collector. At the output stage. Okay, so the simplest form of this operational amplifier is it is used as a voltage amplifiers. Okay, voltage follower. Next one is inverting amplifier, and next one is non-inverting amplifier. Okay, so now let us discuss the symbol of this op-amp. One is a non-inverting terminal. This plus is a non-inverting terminal. So this is your non-inverting terminal, and this is your inverting terminal. Okay, you have two supply. One is minus VCC and the other one is minus VE. Here is the DC power supply, which ranges from plus or minus 5 to plus or minus 22 volt. Okay, so this is your non-inverting and inverting terminal. So totally you have two input terminal and one output terminal. Okay, so this is your symbol of op-amp. So let us discuss what is present inside this op-amp. Okay, I told you on the first stage you have a differential amplifier, right? So one is this is your so this is your V1 and this is your V2. Okay, and here you have a emitter resistance which is connected to minus V. Okay. So this is your IC1, the current which is flowing this one, and this is IC2, and this is your RA. Right. This is RP. And this one is connected to a common character source. Okay. Sure, it did. So I can write IC1 plus IC2 is equal to IE, right? So from this one, if both current are saved, I can write 2IC, right? 2IC is equal to IE, and I can write IC is equal to IE by 2, right? So if you see, this is your differential amplifiers, right? This is your differential amplifier, and this one is your level shifter, and this is nothing but your emitter follower. Okay, so now let me explain the circuit. Okay, so suppose if positive input is given to V1, and this is a case 1. Okay, case 1, positive input is given to V1 and V2 is grounded. Okay, E2 is grounded. Therefore IC1 is increased, right? IC1 is increased and IC2 is decreased. Okay, so therefore what will happen? This IC1 is increasing and this IC2 is decreasing. Means there is a decrease in the voltage drop across the resistor RC. Okay, so if there is a voltage drop across this RC, then this VB3, okay, this VB3 has to be increased. Okay, this VB3 and VC2, VC2 is this one. Okay, this one VC2. Okay, so the VC2 has to be increased. Okay, so this will produces, therefore it will produces the positive going output voltage. It will produces a positive going output voltage. Okay, this is the first case. Okay, so the case 2 is if negative input is given to V1 and V2 is grounded, E2 is grounded. Okay, IC1 is decreased and IC2 is increased. Okay, this will increases the voltage drop across the RC resistance. Okay, so this will reduces the VB2 and VC VB3 and VCE2 is decreases. This will produces negative going output signal. Okay. So what happened to this V1? V1 is nothing but this is nothing but a non-inverting terminal. Okay. Non-inverting terminal. Okay. Next one is case 3. Okay. Here V1 is grounded and V2 is positive going pulse. If V2 is positive going pulse, IC2 is increased, right? IC2 is increased and IC1 is decreased. If IC2 is increased means what happened? If IC2 is increased means IC1 decreased means there is an increase in the voltage drop across, increases in the voltage drop across the resistance RC. Therefore, VB3 and VC2 is decreases. This will produce negative output signal, right? So if I give a positive signal at the V2, I will get a negative signal. Okay. So next one is case 4. Okay. Here V1 is grounded and V2 is negative going pulse. Okay. This will reduces the IC2 value and IC1 is increased. Okay. Because this has to be equalized. Therefore, there is a decreases in the voltage across the collector resistance. Therefore, VB3 and VC2 is increased. So this will produce positive output signal at the output, right? So for the V2, I have given a negative signal. I am getting a positive output. So therefore, the V2 is called as inverting terminal. Okay, I hope you have understood this one. So let us discuss one problem based on this. Okay. So here they are given VCC is equal to 10 volt and VE is equal to minus 10 volt. Okay, and I have given V1 and V2 is equal to 0. RA is equal to 47K and RP is equal to 100K. Okay. Next RC, RE and the RE3 is equal to 4.7K. Okay. So assume that Q1 and Q2 is perfectly matched. Okay. Okay, and they are asking about what is V0. Okay, for this one, you have to look into this circuit. Okay. So first, let us discuss this. Let us take this part. Okay, that is V1. V1 is equal to, I can write V1 is equal to VBE plus VRE, right? V1 is equal to, this is your VBE, okay? plus VRE. This is your VRE. Plus VE, right? So I can take VRE is equal to, this is your 0, right? This is 0. They are given VBE minus VE, right? So how can I write? This is VB is nothing but 0.7 and VE they have given us minus 10 volt. Okay. So from this I can take this value as 9.3 volt. Okay. So if VRE is 9.3 volt, we know the value of IE. IE is equal to VRE divided by RE. That is nothing but 9.3 divided by RE is 4.7 K. Therefore, it is 1.98 milliamps. So we know that IC is equal to IE by 2, right? So what is the IC value? 9.8 divided by 2, that is nothing but 0.99 milliamps. Okay, this is nothing but your IC1 and IC2. Okay, so if IC1 and IC2 value is given, so I can take the VRC value. So what is the VRC value? VRC value is this is your VRC and okay, this is your VRC value. So this is nothing but IC2 into RC. It is nothing but 4.65 volt. Okay. So next I need to find the value of, so I can from this, if I take this portion, okay, if I take this portion, I can write it as VCC is equal to VRC plus VRA-RB plus VE. Okay. So I need to find the value of VRA-RB. So therefore this is nothing but 10 volt minus VRC. I have already find it out as 4.65 minus VE. Okay. So 10 minus 4.65 minus of minus 10. So which is nothing but 15.35 volt. Okay. So once this VRAB, so this is nothing but VRARB. Okay. This portion. So this portion is VRARB. So I can write, so this is VRARB. What is this value? Okay, that is what they are asking. So VRB, this is nothing but VRB. Okay, so the VRB is equal to RB into VRARB divided by RA plus RB. Okay, so all the values are given. So if I solve, I will get 10.4 volt. So this is nothing but your 10.4 volt. Okay. So I can write this one as 10.4 volt is equal to VB3 plus V0 plus VE. Okay. So I can find V0 is equal to 10.4 minus 0.7 minus VE. So this is nothing but 10.4 minus 0.7 minus of minus minus 10 volt. You get this value as V0 value is equal to minus 0.3 volt.